everyone. Here I am Vadel Sagar. Welcome to the part number 6 of the chapter number 1. This is the last part of this our present discussion regarding the chapter number 1. Then we proceed for the our basic physics inside the chapter number in the standard 11. So let's start without wasting time. The today we focus on the chapter topic the nature of physical laws. The natures are following the physical laws, set of laws which are has to be obeyed, then and then nature can survive, or the nature has to be, or nature is following completely. The physicists are always trying to explore the universe. Their investigation is the based on scientific processes range from the particles or atom to the or star like system, so the very tiny to the microscopic to the macroscopic world. In the addition to the finding the fact by the observations of the experimental physics, an attempt to discover the laws and its summarization. So always scientists what's doing, they are trying to putting experiments, and through which they are judge the experiments, and they trying to justify the one law at the end. So that law is followed by the nature. In any physical phenomena governed by the different governed by any physical phenomena governed by the different forces, several quantities are may change with times, and suppose few times it will be not changing with time. A remarkable fact is that some special physical quantity, however, are some of them which are constant with the time. That is very important, and they are the named as conserved quantity of the nature. Understanding of those conserved principles that we aware about in the 10th class, conservations laws of momentum, energy, okay, mass. It is very important to describe the observed phenomena quantities. For a motion under the external observation force, some motions are happening. Today we are just I can understand this may go in your bounce ball like structure today what we discussed, because this is a whole physics scenario we are seeing, yet you are not seeing the physics which we concluded in the 11th 12th class. So it can may have a some of the things are not going to be understand fully to you, but yes, you have to accept it. This is not askable in the exams. For the this chapter is just to give the vision in a physics, not more than that. Okay, so don't be any kind of thing which is okay, so you may not having worry about these things. The familiar example is the free fall under the gravity. You may aware about in these things in the 10th class also, free fall under the gravity, and we are trying to, yes, actually it is coming in the 9th class, kinematics chapter is there. So there we are seeing the energy of the systems. What will happen, let us see. Both the kinetic energy of the objects are the potential energy change continuously. If we are just lose the your ball from the topmost level to the ground level, so when you kept it is a having potential energy, but when you lose the ball it is a free fall under the gravity. So the what the potential energy it has in a steady state, it continuously converting with the times the kinetic energy, but the summation of the potential energy and kinetic energy is the same. It means fixed. That is called conservations of the energy. Okay, if the object is released from the race, initial potential energy is completely converted into the kinetic energy of the object just before hit to the ground. This is the law restrict the conservations force should not be confused in the general conservations of energy in isolated system, that the nothing but the which is the basic of the first law of the thermodynamics. You will be aware, see in the thermodynamics chapter in the 11th class. The general law of conservations of energy is true for all the forces. The general law of conservations are the obeying for the all forces. That is very important for the any kind of transformation between the different form of energy. From the suppose you have a spring, then you are compressing, it means that has potential energy. When you are release it, it will be converting into kinetic energy. So this is the transformation of energy. When you are capturing a ball and you are free fall under the gravity of the ball, then you are converting potential to the energy. But when you are eating something, so your chemical energy converting into the storage energy, APT, ATP. And if you are using your chemical energy into your work energy, it means you are running mechanical energy. This is called the transformations of energy. General law of energy conservations, however, is still applicable. The initial potential energy of the stone gets transferred into the other energy forms. Sometimes if you are summed it, it will be not going to be constant, but because while it is transferring, while it is travel in air, it has friction with the air. It may convert some heat, and sometimes also at the ground state they heat up that produce sound. Sound is also one of the energy form. So that may causes, when you are summed up everything, you have to care about the heat, sound, and other all, maybe probably, though number of kind of transformations happen when the just simply the ball falling practicals. So this is a too much complicated physics. While we are carrying, our careness will be increased in the order of highest in level with your experiment. Ultimately the sound is after observed by the, because heat, the total energy of the system, the stone plus surrounding, is remain unchanged. The law of conservation of energy is thought to be valid across all domains of the physics, which is microscopic whether it is a macroscopic whether it is. It means from the article size to the atomic or the star size, is routinely applied to the analysis of the atomic, nuclear, and elementary particle of the processes, until the evidence of the Einstein theory of relativity, which is nothing but the E is equal to mc square and the basics of the space. The law of conservation of mass was regarded as any other basic conservation law of nature, since matter was thought to be undirectible, indestructible. Okay, in a nuclear processes, mass gets converting, and the mass is energy, and energy can convert into mass, which is called E is equal to mc square. That we are number of times seen in 10th class also, I explained it. Energy is the scalar quantity, but all the conserved quantity should not be, it is not fixed that it shall be conserved. So energy is conserved and still it is scalar. It is not a mean that all conserved quantity are going to be scalar. Few of are there. Still the total linear momentum and the angular momentum is always conserved. It should be in the conserved in the system, but it is not a scalar quantity. This is the way on which it can be. These laws can be divided from the Newton's law of motions in a mechanics, but the validity goes beyond the mechanics. So these are the basic conservations law of nature in the all domains. This can be has to be do in the atomic level to the your star level. They are the basic conservations laws in the all domains, even those where Newton's laws may not be applicable, but it's produced by the Newton, but still it is applicable to the all physics, quantum to the microscopic, classical also. So this is, I am taking direct the screenshot from the my book NCRT. Why? Because I have a lack of charging and then the lights are not there, so that's why. But still I am trying to explain you. Continuous law have a deep connection with the symmetry of the conservations. Whenever the conservations happens, the deep connection with the symmetry of the nature. What kind of symmetry that you may explore in a more in advanced course in the physics. For example, the an important observation in that the law of nature do not change with time. So the laws which are not changing, your baby and it's your in the baby will study the physics. It means law will not change, theory background will be changed. So this is the important thing, it will not change with time. If you perform an experiment in the laboratory today and repeat and some experiment after a year, the results are bound in the same start. It turns out that this symmetry of the nature with respect to the translation in the time, so it is do not with change with times. Okay, translation in this time, the equivalent to the law of conservations of energy, like space is homogeneous. It means homogeneous means એક જ વસ્તુનું બનેલું. The space is the something which is made up of homogeneous material, and these are now preferred location in the universe. એવું નથી હોતું કે અહીંયા એક્સપેરિમેન્ટ કર્યો ઇન્ડિયામાં, that will go results are this, and if you are go in America then result will be different. No, it is not depending on the location. It should not be concerned. It should not also. To put in the more clarity, the law of natures are same everywhere in the universe. Caution is, the phenomena may differ from the place to place but because a differing condition, all different location. For example, the acceleration due to the gravity at the moon is a 1/6 of the earth, that we are aware, but the law of gravitation will be the same for the both one. This is the important thing, which is called symmetry of the nature. This symmetry of the law of nature with respect to translation in the space give rise to conservations of the linear momentum. In the same way, the isotropy of the space, no intrinsic prefer the direction in the space underlying to the law of conservation of angular momentum. That is the conservation law of charges. Then it is other attributes of the elementary physics can also be related to the certain abstract summary. The symmetry of the space and time and other abstract symmetry plays central role in a modern theory of fundamental forces in nature. The symmetry is also driven the conservations of laws. I can understand these are some of the things which is goes beyond your level. Yes, as I said you, this chapter is give the visionary to the new upcomers in a physics. There is too many things which is not yet is you are not able to understand. I am not restricting to you. If you go and search on the googles, you will find lots of information, but you should have interest in it. So if I am spending in the time for the explaining the each and every field of the physics, what I am trying to say, the conservation law of charges and all that, I can't afford that much time, because we have a too much syllabus in this year also other. But these are the things I can say, that these are the things are you will learn in the 11th as well as in the 12th also. So this is what we have in the chapter number 1, which is an introduction of the physics, what the physics is. Hope you understand what the physics is in the during the 6th part of the first chapter. And from the next time we started our chapter number 2, or maybe next anything which is suitable for the next session. Thank you very much for the today's spending times. Please show some love on this, it means give the feedback on the video by the like, by the comment, anything which you want to do. Anyway, you can contact to me that you have such kind of suggestion or any kind of correction, anything. If you share with me, I will be happy for that. Thank you very much.